Hello, you guys. Let's talk about the last lesson in chapter 11, scatter plots and line graphs. So a scatter plot is kind of cool. It has an x-axis and it has a y-axis, and it has these little dots all scattered about, okay? They're not connected. They're just scattered all about. Oh, and Fiona's back from her walk. Okay. And then a line graph also has an x and a y-axis, but it has dots that are connected dot to dot in little line segments, okay? They're all connected. And I think that's all I want to say right now. Okay, now I want you to add some extra notes to this page, okay? You can put it in the margin or down at the bottom. And I want you, please put extra notes, and I want you to draw an x-axis and a y-axis. And I want you to label the x-axis as the number of hours studying. And I want you to label the y-axis as test scores. And I want you to put some dots. Let's put about 10 or 12 dots. And I want them to kind of trend upwards. Then I want you to grab your red pen, and I want you to draw a line kind of going up, up, up. And this is an example of what we call a positive correlation. So the way that you can explain it is always grab the x-axis, the hours, and then let that increase. So imagine that the hours you study go up, 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 up. And then predict what would happen to test scores. Well, test scores also would go up, up, up. So there's what we call a positive correlation when the arrows match. Okay, I want you to do another example. Draw an x-axis, and that's going to be the temperature in a classroom. And then I want you to draw the y-axis and test scores. And now I want you to draw dots that kind of trend down, 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 okay? And then use your red and draw a line going kind of down in the middle of the dots. This is what we call a negative correlation, and let me explain. As the temperature in the classroom goes up, 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 so imagine it's getting hotter and hotter and hotter in the classroom, that test scores, just as you expect, will go down. And so that's what we call a negative correlation when we see the dots kind of going down, down, down. Now there are some things that we try to compare that have nothing to do with each other. So let's say on the x-axis I put people's ages, and on the y-axis I put the number of pets they have at home. And then just draw some dots all over the place. Because as somebody's age increases, it doesn't necessarily mean that the number of pets they have increases. Because remember, babies in the home could have lots of pets, or babies in the home could have no pets, or an older person could have lots of pets, or they could have no pets. So there really is what we call no correlation. Okay, so let's make a scatter plot. So they say tree heights. The table shows the height of trees each year for 6 years. Make a scatter plot of the data. So remember, the first item they give me goes on the x-axis, so draw your x-axis and label it years. The second item is your y-axis, so draw your y-axis and label that height in centimeters. And then we're just going to graph those points. So the first point we graph is 1, 60. So go to the right 1, get in the elevator, go up to 60, put a dot. And then we're going to graph 2, 115. So go to the right 2, get in the elevator, go up to 115, put a dot. And then graph 3, 165. So start at the origin, go to the right 3, go up to 165 and put a dot. And then graph 4, 210. So go to the right 4 and up to 210, put a dot. And then 5, 250. So go to the right 5, go up to 250, put a dot. And 6, 285. So go to the right 6, go up to 285. And you'll notice that these dots are trending upward. They're going up, up, up. So this is what we call a positive correlation. Another way to look at it is just take the years and take the height and then let the years increase. So you know, as a tree gets older and older, it's going to grow taller and taller. So the arrows match. So that's another way to show me that you know it's positive, it has a positive correlation. Okay, so go ahead and lightly cross out this guided practice, and this may be where I have you put the movie clue later. Okay, take a look at example 2 with me, interpreting a scatter plot. So look at the x-axis is the number of months on a shelf that the DVD player is, and so label the x-axis months, okay. And then the y-axis is the price of the DVD player, so the y-axis, and put the price in dollars. And then we're going to make a scatter plot. So we're going to graph 0, 215. So I'm not sure why they wanted us to go to the right 0, but all right, go to the right 0, be at 0, and then go up $215 and put a dot. And then go to the right 3, go up to 210, put a dot. Go to the right 6, go up to 199, put a dot. Go to the right 9, go up to 184. Go to the right 12, go up to 167. Go to the right 15 and go up to 140. Okay, and now, even though it's kind of slight, do you see if you drew a red line that it would kind of be trending down, down, down? So this looks like it has a negative correlation. And that makes sense, right? Because if we take the months and we let the number of months go up, so the number of months that DVD player is sitting on the shelf and nobody's buying it. So as that's going up and up and up, the price needs to come down, down, down so that people will eventually buy it. Okay, and so when the arrows do not match, that's what we call a negative correlation. Now they wanted us to estimate the price of the DVD player after 18 months. So if it continues on this trend, it's going to go down a little bit more after 18 months. So you might say that it's definitely going to be lower than $140. So maybe it would be $120. Okay, so that was just an estimate. But as long as you estimated something less than $140, that would be really smart. Okay, so look at example 3, making and interpreting a line graph. Now, a line graph is different from a scatter plot because we're going to connect the dots. Okay, so this is, the table shows a number of visitors in hundreds of thousands to a zoo. Make a line graph of the data. What happened to the number of visitors over time? Okay, so remember, the first item they give us is the x, so draw your x-axis and label it years, and then the y-axis is the number of visitors in 100,000, so the y-axis, number of visitors in 100,000. All right, and so let's graph this. At 1999 it was 2.4, so go up to 2.4, and then 2000, so go to the right, 2000, go up to 3.5, and then go to the right to 2001 and go up to 4.3 and put a dot, and then go to the right to 2002 and go up to 5.8 and put a dot, then go to the right to 2003, go up to 7.1 and put a dot, then go to the right 2004, go up to 7.9 and put a dot, and then go to the right 2005, go up to 8.6 and put a dot. And now notice I switched over to my blue, but just connect the dots in straight line segments. Connect the dots. Okay, so what do we notice? Well, we notice that this line is going up, up, up over time, so we can see that the number of visitors has increased over time. And that's all you would say. The number of visitors increased over time. Okay, so let's do this guided practice together. Make a line graph. So remember, we're going to connect the dots of the data shown in the table. So the x is the years, so put your x-axis, and I should have labeled that years. Go ahead and add that. And then the y-axis is math club members. So put the y-axis, and these are the members of the math club. And then graph each data point. So 2001, it was 10. So go to the right, 2001, go up to 10 and put a dot. And then the next point, go to the right, 2002, go up to 9 and put a dot. And then go to the right, 2003, and go up to 12 and put a dot. And then go to the right, 2004, and go up to 15 and put a dot. And then go to the right, 2005, and go up to 19 and put a dot. Okay, so that's our line graph, and now we have to, it says, determine the time period when the number of math members increased the most. So which of these line segments was steeper or went up faster? And so I can see from the last, from 2004 to 2005, it's the steepest. It increased the most. It jumped up the most. So that's why I said from 2004 to 2005, it increased the most. Okay, so this is an excellent summary. So please, using appropriate data displays, this is worth everything. We only use a circle graph to represent data when we know we have 100% of that data. Okay, that's when it's appropriate to use a circle graph. A line graph, the one where we connected the dots, that's great to show us change over time if we want to see how something's changing over time. Stem and leaf plots are really good to help us order data. So we can put data in order very, very quickly with a stem and leaf plot, even if we have a lot of data to organize. A box and whisker plot is great to show the distribution. That means the range. How spread out is the data? And it's a great way, box and whisker plot is a great way to see the median of data. And you can also see the median of the lower half, the lower quartile, and the median of the upper half, the upper quartile. All right, and then bar graphs are really good to use to display distinct data items, like different types of pies people like, or different eye colors or whatever. That bar graphs are great for distinct categories. Histograms are really good to compare the amount of data that are grouped into equal intervals. So remember, you can't tell me specific data items with a histogram, but you can tell me how many data items there are in a certain range. So remember the waterfalls, like we knew how many waterfalls were in the 300s or how many waterfalls were in the 400s, for example. And then scatter plots, when they're just those dots, we're looking to see trends. We want to see if there's a positive correlation between the items or a negative correlation, or there's no correlation. So we're looking for trends. Okay, so take a look at this last example with me, choosing an appropriate display. The data displays organize the time and minutes you spent jogging on a treadmill each day for 7 days. Which display can you use to find the median jogging time? So just by looking at it, you would know. So this is our line graph. Day 1, day 2, day 3, day 4, how many minutes I spent jogging. And then this is the box and whisker plot. And the box and whisker plot, this middle dot is the median. So if they're asking me to find the median, I'm going to use the box and whisker plot. That is the best. It's visual, it's a picture, I can see it, and I would know the answer just by blinking and looking at it. Where the line plot really doesn't help me because it didn't put the times in numerical order. It put them by the order of the day, not by the order of the times. So it'd be harder for me to figure out the median looking at that line graph. Okay, so I want you to put the movie clue where I told you to do that earlier, and I just want you to tell me what your favorite display was that you learned in this chapter. You can pick any of them, just tell me which one was your favorite.